Alrighty, good morning everyone. So today we're going to be having a look at some of the applications. In the next few lessons we're going to be looking at some of the applications of trigonometry. In particular the calculus around trigonometry, and we're going to have it to be using basically all of the skills we've learnt up to this point all together. The first thing is that we've learned how to create tangents for other sorts of functions. Let's learn how to create a tangent for a trigonometric function. So just as a reminder of what a tangent is, if I draw a beautiful little picture, this is my trigonometric function. This would be a cosine function because it's starting at a maximum. If I wanted to know what the tangent was here, it is the straight line in which the slope of the line matches the slope at that point, but it also passes through that point. So just in your head, that's what we're trying to do. So in this particular function, we have got a cosine function. So it's me drawing my cosine function. And we're asking it pi on 3. So if 2 pi is over here, oh sorry, not there. So if 2 pi is up here, where it repeats, that means pi would be down here. So a third of pi is going to be approximately about here. And so the tangent should look something like this. Alrighty. So this is the sort of picture we're looking for. And so we're wondering, well, what is the equation y equals mx plus c of this line, the straight line? So there's 3 things we need to do when finding tangents. Number 1, find the point. Number 2, find the slope, or the gradient, or the derivative. And then 3, y equals mx plus c. Alright, so this is our 3-step process. Step 1, find the point. So that's f of pi on 3. It is the function evaluated at the point we're interested in. So we get cos of pi on 3, and cos of pi on 3 is a half, and so my function is evaluated there. Alrighty, so I now know that I've got a point, and the point is pi on 3, a half. Step 2, find the slope. Well, first of all, I need to find the derivative. So the derivative of cosine is negative sine. And the derivative evaluated at pi on 3 is negative sine pi on 3. And in this case, it's negative. All right, because negative sine is going to be negative. And sine pi on 3 is root 3 on 2. Alrighty, so that tells me another piece of information, which is that the derivative of pi on 3 is negative root 3 on 2. But also that this is then equal to the gradient, right? Because what we're saying is that the gradient of the tangent needs to match. So, step 3. We know most of our equation, y is equal to negative root 3 on 2 x plus some constant c, and we have a point. We've already used this piece of information here to get our gradient. So the only thing we've got to do now is substitute in this point here, pi on 3 a half. Substitute that in, we get a half is equal to negative root 3 on 2 times pi on 3 plus c. Bit of fraction multiplication gives us negative root 3 pi over 6 plus c. Add root 3 pi on 6 to both sides. We get a half plus root 3 pi on 6. Make the denominators of the fractions the same, so we get 3/6 plus root 3 pi on 6. And we get that c is equal to 3 plus root 3 pi all on 6. So a little bit of a trickier algebraic part there at the end, but mostly just managing with fractions. And so we get y is equal to negative root 3 on 2x plus 3 plus root 3 pi on 6. And I think a really important part, even though this was a tech-free question, when practicing this sort of stuff, a great way to check is to actually put it into your calculator and actually see what it looks like. And you can see there, the tangent, this blue line here, perfectly hits this point here on our function. And you can see it actually hits it a few times, but this is the point we're interested in. Right. So there's a little bit of a go at doing tangents on trig functions. See you in the next one. Goodbye.